what's up everybody? Welcome back. We are going to do admin code day 10 today. It is the 17th of December, so we are a week behind, but technically only 2 days behind as there are only 12 days. And, you know, the goal here is for us to have fun, right? That's first and foremost. So we might do a solution that is not the easiest solution. We might do the easy solution depending on if the problem looks hard, but more importantly, we're going to do the solution that seems most interesting to us. So we've kind of done that in the past where we've kind of taken a more complex approach to the problem to try to get something that runs faster or whatever. And so the story is we are an elf. We are going into the North Pole's secret bunker. This is like an ASCII image. We're trying to get all the way down to the bottom to ship out Christmas presents on time or something. I don't remember. So day one, we entered the secret base by finding the password. We went to the gift shop. We helped someone fix a bunch of broken database IDs that a kid messed up. We fixed an escalator, went down the escalator and ended up in this like gift receipt room where we helped optimize their movement of paper pallets so that we could free up a forklift to bash us through the wall, which got us into the cafeteria where I think that we just wanted to help our friends deal with a computer problem where they couldn't track fresh fruit easily. We were goofing off, fell down the trash chute, ended up in the trash chute where some cephalopods lived, and so we helped them do their cephalopod math for their children while the adults helped us get out, which brought us to a teleporter room. The teleporter room, we got stuck in a teleporter that we had to fix. We had to do some, I think they called it like something quantum something, I don't remember. But we fixed the teleporter, ended up in a playground. In the playground we helped put up the Christmas lights, and then what was the last thing? We ended up in the movie theater where we were trying to optimize the tile layout on the ground such that they could make like a big box. They wanted to make a big box with the tiles that they had. But now we're on to day 10. So I assume that we are, like, does it talk about us leaving? No, we just do the stuff. Day 10. Across the hall, we found a large factory. Fortunately, the elves here have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline, and none of the elves can figure out how to do the initialization procedure. The elves do have a manual for the machines, but the section detailing all of the initialization procedure was eaten by a Shiba Inu. All that remains of the manual are some indicator light diagrams, button wiring schematics, and voltage requirements for each machine. For example, okay, so indicator light diagrams, button wiring schematics is probably the stuff in parentheses, and then voltage requirements are probably the parts in squiggle brackets. So we see this guy has 2 lights on, some wires that we can connect, and voltage requirements. Okay, cool. Manual describes 1 machine per line. Each line contains a single indicator light diagram. Nice. Oopsies. 1 or more button wiring schematics and voltage requirements in this. So do these like numbers match up in any way? Like, we have 4 things here. We have 4 things here, right? So 5 and 5, 6 and 6, right? So that's a clue, right? And then it looks to me like the indexes, like if these were indexes, they would be 0 indexed into this list, right? So you can probably like connect 3, or 1 and 3, or 2, 2 and 3, 0 and 2, 0 and 1, and then probably these are the voltage requirements of each output, I would guess, right? So like if you use index 3, you have 7 volts. Probably somewhere they're going to tell us that we have a maximum voltage, would be my guess, but we'll see. The indicator lights must match those shown in the diagram. Okay, where dot means off and hash means on. Got it. Machine has a number of indicator lights shown, but its indicator lights are all initially off. Oh, okay. So an indicator light diagram like this means that machine has 4 indicator lights, which are currently off, and the goal is to make the 2 middle ones on. Okay. You can toggle the state of indicator lights by pushing any of the listed buttons. Wait, buttons? Okay. Each button lists which indicator light it toggles. Oh, I thought these were wires. Button wiring. Ah! Oh, I see. So we can toggle by these, and you could do some sort of puzzle where you have to like click them in some order to get them to flip to the right thing. When you push a button, each listed indicator light either turns on or turns off. You have to push each button an integer number of times. There's no such thing as 0.5 presses, of course. So a button wiring schematic like 0, 3, 4 means that each time you push that button, the first, the fourth, and the fifth indicator lights would all toggle. Great. Wonderful. Easy. Because none of the machines are running, the voltage requirements are relevant and can be safely ignored. So this is going to be for part 2, right? They're going to try to make sure that we don't exceed some limit, probably. You can push each button as many times as you like. However, to save on time, you need to determine the fewest total presses required to correctly configure the indicator lights. Okay. There are a few ways to correctly configure the first machine. You could press the first button. The first 3 buttons each once, a total of 3 presses. You can press this once, and this twice, a total of 4. Oh, I see. However, the fewest buttons required is 2. You can do this by pressing this. The second machine can be configured with as few as 3 button presses. One way to achieve this is by pressing the last 3 buttons once each. The third machine has a total of 6 indicator lights that need to be configured correctly. The fewest presses required to correctly configure it is 2. One way to do this is by pressing blah, 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 blah. So the fewest button presses required to configure the indicators on all is the minimum each combined. Got it. So this is just a BFS, right? Just a breath first search, right? I don't, like, there's probably, like, maybe there's some sort of, like, intelligent algorithmic approach to this, but I don't want to look for that. It seems to me like the easiest thing to do is just put all of these guys in a list, and then start hammering, like, over and over. Like, every time you press 1, you append all of the possible next items to the list again, right? So you say, okay, I pressed 3, now try, after I press 3, try all of these guys, and you probably know that pressing the same button twice in a row is useless, right? That'll just get you back to the same state. So you can at least say, after I try this, try all of these guys. And then you just have to try that for everybody until you find an answer. And hopefully the number is small enough that your, like, list of elements doesn't get out of fucking hand, right? Seems pretty reasonable. How many things are there in here? Okay, good news. Each list here looks relatively small, right? Like there aren't, like, a ton of buttons, which is good. I assume that the depth of all of these is not insane. Okay, so let's do that. Intro part 1 problem statement. And let's say part 1 solution. Okay. I guess we need to get into a reasonable spot. Because we were working on our VLC plugin before this, but that's not what we're doing anymore. We are in admin code. Day 10. Day 10. Okay, so the first thing to do is parse the input, right? Oops. We probably want to be in an environment that has Zig. Whoa, really? Let's get Zig somewhere. Zig 015 point something. I don't know which one we're on. Somewhere on there. Alright. Day 10. So we of course need the standard library. And we are going to have some sort of what? F is try stud fs. Open current working directory. Open file. What's your work program? Probably somewhere between like 110 and 120 is what we get when we play typing tests. Day 10. And in here, we probably want to do some sort of, we need a reader. Reader buff. Reader buff is, let's make a 4K buffer. Boom, and we go like while what? True, I guess. We go reader, interface, take until new line. This is the line. We're assuming that each line is less than 4K characters. If it's more, go fuck yourself. If we see an end of stream, we are done. We are done parsing, and otherwise it's a real error that we have to bubble up. Then, how do we parse the line again? It is, So we're trying to find the desired state. So it's like line. I guess let's do this. Parse desired state. And this, I think we're going to actually use an allocator for once in our fucking lives. And I think this is... I'm just going to do like this for now. A slice of enum on off. Maybe we say like LED state, right? But it might be better for this guy to instead be like a packed bit set. You know, something like that. Then we are looking at the reader. And here we're first taking take byte. Okay, can we do something like this? Is there a way to like factor out this logic, this like end of stream break, else return E? I think so, right? I think you can do something that's like wrap reader res that return. It's not that easy. It's not that easy. I guess the real answer is we move everything down a layer so that we can kind of just do this at the top, right? So we turn this into... Oh, no, it's okay. Because the line parsing is the only problem. So if anything else fails here and we see end of stream anywhere in here, it's an actual error. So we're actually chilling. We're actually so chilling. Okay, so we're expecting this. I'm just going to assert now. Oh, if we can error, fine. We can error. Okay, so if this is not equal to an open brace, error unexpected, right? Then while, you know, do we want to search once until the end to find the length up front? Probably, right? We need to scan till the close delimiter for us to know the length. So we have two options, right? One is that we go character by character and we like have like an array list that grows as we push stuff into it. That's one option. That's probably an okay answer if we guess the initial size well, right? Or we jump to the end, get the length, and allocate something that is exactly that size. Right? And something that so sometimes we use like linear allocators. So if we had like fixed buffer allocator, right? Hear me out. Where we say like, you know, we have you know, like 100 bytes or something in here, right? Something that we could do is we could like we could alloc max buffer, you know, like populate and then like shrink allocated segment. This is like a strategy I use sometimes, but without like all of our allocator stuff, that's like a little bit of a pain. But that way you can have the best of both worlds, right? You would not over allocate and you wouldn't have to parse twice. But in a world where we have to allocate stuff of sizes that come from some sort of like more complex allocator that we don't know its internal implementation details, we have to make that choice, I think. But I'm just going to say that that choice doesn't always have to be made, and I think the best answer here is to only parse once and have the right size allocation, right? But we can't do that right now easily. So instead, I'm going to opt for the double parse method. So you know, what does it take? Delimiter exclusive. So we are looking for the end bracket. And we'll say this is the LED state. And actually, what we can actually do here is we can get crazy. We can get crazy. This guy is backed by this. This is this, and this is this. And then I think this technically just works, right? Because we're not trying to pack this stuff into a bit set, which we could be doing. I think that we can just return this. I think this is allowed, which is kind of funny. Which means that he doesn't actually need the allocator because we can read directly from this guy. However, we can't read. The reader's buffer will change over time, so we cannot like hold this forever. So we do need to do a little bit of this. LED state like this. And then I guess it's like this. Boom. I think something like that will work. Okay. We'll try working with a fixed allocator for now, but we'll see if that goes okay. Alloc buff. Let's do 1 meg. We have 8 megs of stack space, so if we fuck this up that bad, that's crazy. Okay, so now for each line, this goes into some... well, I guess we can parse one line at a time, right? There's no need to, like, package all this together. So this is a desired state. And we can actually then, if we're going to do this stuff line by line, we can checkpoint the allocator. So maybe we could have actually got away with this the whole time. Maybe. If you fuck it up, just increase the stack size. Easy. Yeah, yeah. So maybe we could have got away with the knowledge if we of passing in the fixed buffer allocator here. Maybe. But fuck it. You know, whatever. Whatever. Okay. So now we parse each button. So while true, we are getting the button toggles. So you probably you can probably get kind of crazy where you do something where you like XOR these guys, oh, it's fine. I was gonna say, like, maybe it makes sense for each of these guys to be represented as another set of lights. But I think that's wrong. I think that's wrong. Okay, so let's do something like parse button. And I think it's like we probably want to give him button def like this, I think. And are they trimmed? They are, which is kind of nice. So this is going to be a bunch of U sizes, I guess. You could probably get away with U8s. And here we take in the button def. So, okay, so we need some sort of thing where we get the button definition. So we have, I guess we need line reader. Like this. Cool. And then here, it's like, while we can get an end bracket here, we can parse the button, right? So it's like, while line reader take delimiter inclusive, maybe? Not sure. So what does this return? Returns a slice of the next byte of buffer data from the stream until delimiter is found. Return slice includes delimiter as last byte. And so I assume that if this thing does not exist, he will say end of stream. Okay, so I think this is kind of the same, where it's like, we have like button def here. Button def is equal to this. Then we probably want to do like parse button with button def but trimmed. Maybe this goes below. Um, maybe something like this. And we're doing something like, you know, if trimmed 0 is not equal to this, we have a problem. Maybe, do we do a reader again? Probably not. Stud mem index. We probably have like iterator here. I don't know. I don't know yet. We're feeling it out. Uh, return error invalid button. Boom, boom. So we start at 1. We do like stud mem index of scalar from iterator onwards. Where we're looking at like this guy. So we're looking for a comma. Are we assuming single digits for all these? Nah, we actually probably can by chance. Unclear if that matters. The joltage stuff won't, but that's okay. So I guess we just go this. For 1, I guess like while it is less than trimmed len, it plus equals 2. Stud debug assert it 1 or what, like trimmed at it plus 1 is equal to this. If not, then it's like not just, I guess if we'll return if this is not equal to this, return error unexpected. And then it's like here we can probably guess the size actually. Right, so like the size of the output is trimmed.len minus 2 over 2. Right, so you take out the 2 brackets, then assume a comma for each one, except there's not a trailing comma after the last one, so trimmed.len minus 1 over 2, I believe gives us the right size. Then here we're actually gonna track I as like the index into ret. And we're gonna say while I is less than ret len, I plus equals 1, right? So we could even do this like for ret even. Like this, maybe. Elem I, like this. Okay. Then we have trim in like S index is I times 2 plus 1. Great. Cool. And then we look at trimmed. So it's assert that the next thing would be a comma or an end brace, that's okay. Then we do ret at, I guess it's just like lm is equal to trimmed s index minus 0. Wowzer! Wowzer! Easy. Okay. And then here, I guess we know, do we know how many buttons there are? Button list length is unconfirmed, but we will just say var buttons. We'll just give them, we'll just say that there can't be more than like 10 of them. You know? Buttons is a stud array list of slice of U8, right? And in here, it's like each button, we're initializing this from some buffer of buttons buff. Okay, sick. So now all I have to do is say buttons append this thing. And now we should have all our buttons. And so we should be able to, let's just do a little std debug print of this into this. So this is desired state and buttons items. All right, and let's start with the example. That will be easier. Huge for us, and let's copy paste that example somewhere. Whoop! Day 10 input example. Johnst. Okay, we'll do this about 12. What's this about? Expected type this thing. Did I not try something else? Try reader. LED state. Found day 10 LED state. Oh. Oop. Is. No, still wrong. Expected this thing, found that thing. Expected an error union thing. Oh, with a single LED state. My bad. My bad. There we go. 64. He's mad about some bullshit. Trim. He's like, please give me the fucking type, bro. Fine, if you're gonna fucking be like that. Whoa. Probably like this. Probably like that. Expected this, found that. Forgot to write try here. Invalid button. Interesting. Let's look at what this thing is. We fucking suck ass at parsing, I guess? Yeah, because we did the line, huh? Parse button def. This should be from line reader. Close. So we're hitting invalid button. Oh, I actually don't understand. Hold on. Ah. Interesting. So this guy. This should be inclusive, by the way. Oh, there we go. Nice. Nice, better. So now we have off, on, off with 3132230201. Great. So now we have all of the stuff. Now we just have to try to like make pattern. So we have desired state and buttons items, right? And I believe we need one place for us to play with the output state, right? So we're gonna have to allocate that thing. Okay, so we're looking for LED state as like the desired state. And kind of interestingly, actually, you don't actually need to allocate another buffer because flipping until you go from off to on is the same as flipping from when you get to on to off, right? Those are equivalent. So what we can do is we can just modify this state until it's empty. However, we need to track... Oh, is it not that simple? I think it's not that simple. Because if we're doing a breadth first search, unfortunately, unless we do something really clever, we have to write down every state that we ever look at. I think. You know what I mean? Like, every time we make a change, we have to write down that state, which sucks. Which you could fix, by the way, by packing the state into a U8. Well, not fix, but it just makes the cost like way, way, way lower. Instead of having to allocate a new buffer of all these enums, you just fucking slap it into a U8. Yeah, okay. I can't help myself, guys. I can't fucking help myself. The idea of allocating a new array for every node in my breadth first search is like too painful. It's too painful. Like, what is like the longest string here? It's lower than 16. Right? It's probably like something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so it's bigger than 8, but smaller than 16. LED state is a struct. Memory pool. Yeah, I know that you can have a pool, but I like just the idea of the node doing that pisses me off. You know what I mean? It just pisses me off. It just pisses me off. Also, using integers lets you XOR the state with the button to toggle easily. Yeah, that's kind of nice as well. I agree. The XOR is nice. And then you can also, your final check is just like equal 0. All of this is nicer. So we'll do it like this. And so can we, I'm still okay with, maybe we do something like this. Like we say like init from buffer. So this was, we'll just call this lid state char here instead. And we'll start with a LED state char input, right? Boom. And in here, we go what? For input, we have probably like var ret like this. For input, if input is equal to on, we do ret or equals, we probably have some index here, right? If character is on, ret or equals 1 shifted left by I. Something like this, right? Okay. So then now we have return LED state init from buffer of led state char. Wonderful. And now, oopsies. Now the idea of, hold on. The idea of storing the buttons, instead of storing the buttons as a list of things, we store them as the same thing. Like one U16 that we XOR. That's way nicer. Way nicer now that we're bit packing. So let's fucking go. So now this is going to return one LED state as well, I think. Maybe this returns a button state. Button. Maybe. Who is the same. So maybe this type is fucking stupid. But whatever. Shut up. If but poop, else if wiener pee. Shut up. So stupid. Init from from, yeah, we can do something like this. Init from button def. And this thing is definitely failable, right? So this is, I think it's just this loop here. For, I guess this is taking in, like, the button list. And we're kind of assuming that it's like, IT use size is 0, while IT is less than button list len, and we do this IT plus equals 2 thing again. We still do this where we have button list IT plus 1. We are expecting it to be one of these things. If button, I guess we're starting from 1. Yeah. And we're expecting this to be, we're including the brackets in the commas. Okay, cool. Then it's var ret is 0 as a u16. We do ret or equals this is 1 shifted left by an int cast of trimmed at int iterator minus 0. I think that's right. I think it's something like this. If button list 0 is not equal to open brace, return error unexpected. Okay, something like this. So now this guy parse button shouldn't need an allocator anymore. He is going to trim still. And then he is going to say return button init from button def of trimmed or something, which really means that this stuff can go in there. You know what I mean? Button list, and then this function dies. Parse button dies, boom. Then we have buttons is now a list of button. Bang, bang, boom. And then this is button init from button def. Okay, sure. And then can we print this thing? Instead debug print. Probably want a hex format, maybe Boolean format, the first thing, and any format, the second thing. Haven't really decided yet. Maybe custom format, the second thing. I don't really know how they do like slice formatting. We'll see. Desired state. Wait, desired state, isn't this just a U16? This is just a single LED state, right? Yeah. I don't know yet. We'll see. We'll see. Make pattern is mad. Yeah, we're not there anymore. And then 46 is pissed because this guy needs to be pointer cast. Okay, is ret mad? Whoa. This has to be like this, I think, because the comp time shit. 76 is mad because what? Cool. Another comp time shit. So as U16, boom. And then this thing needs to init from button def needs to return the red, if you think about it. If you think about it, you need to return your return. 88 is mad because probably something had to try. Okay, too few arguments at print at 88. True. Okay. So here we have 110, which is great. Do we need to worry about the length of these things? No, I don't think so. As long as of the buttons only press things that are valid within the range, I think we're okay. I think we're okay. I should probably new line here. Okay, so we have 110 for the example. Example. So 0, 1, 1. It's backwards probably. 0, 0, 0, 1. Yep. Then it should be 0, 1, 1, 1, 0, 1. Yep, that's all correct. All correct. So, it should be now that we can do our BFS. So, resolve pattern. And this guy, he does need the allocator to create the like nodes for the breadth first search, or we could like cap the depth of the breadth first search in here, which I kind of would prefer to do. That's kind of more fun. No allocations allowed. No allocations allowed anymore. Because what is an allocation if not just kind of like the stack, you know? Desired state buttons items. Okay. Resolve pattern. So this is now just one LED state, and our buttons is now a list of button. Okay. So then we need a LED state apply button. Right? And we will take this as a LED state and return a new LED state. And this is literally just going to return inner is self inner XOR button inner. Okay. And we need a circular buffer. So this is going to have some sort of items, which is of type node. We'll just call this like BFS here. Each item in the list is going to have, I guess this thing is going to store the buttons, I think. And this node is going to say I came from somewhere, right? So like from is list an index into the buttons list. And then my LED state is LED state. And I think that that's enough for us to continue. You need to make sure it isn't backwards or the buttons will press the wrong light. No, because the buttons are represented with the same flip, right? So button, I'm doing an XOR with something that's left shifted from its index. And then I'm also the same with the LED state. I'm pretty sure. We can confirm that. But I'm pretty sure. We can write some tests if it gets confusing. Okay. So, what we do. Step this thing. What is one step of this thing? I don't know. We probably also want like the depth here, because that's the thing that we care about, right? How many steps did it take to get to the right answer? So we also here have to have our start index and index for our like retrieval thing. So we're gonna model this thing as like, you know, a list of nodes with 2 pointers, and you're gonna kind of say that the breadth first search starts by injecting your first 5 things in here, right? Boom, boom, and then you like cut this one off, process him, and then you pass in, you push in the new nodes, 2, 3, 4, 5 again, move this pointer forwards, boom. Then you process this guy, 2, and you push in 1, 3, 4, 5, push this pointer forwards, right? Boom. And this pointer is like moving this way as we go. Actually, probably. Yeah, I think we might be able to get away with just like a big enough initial buffer. You know? We might be able to get away with just never fucking never wrapping. But we'll try that. We'll see. We'll see eventually. Okay, so we say we can get more advanced if we have to. So this is going to give us a node. Sorry, brain. Return self start index items at the start index. And we increment this thing. We don't bother with error checking anything because fuck us, you know? So we say self pop. And what do? We apply each button, right? So for self buttons, and we look at their indexes. So this is bi. If I is equal to node from, we don't have to process this. Like, there's no point because toggling back and forth does nothing, right? So here we say fuck that shit. But for everything else, we say push a node that has what? LED state is node LED state apply button. Depth is equal to node depth plus equals 1. And from is I. Right? No. Yes. That sounds right. Well, maybe plus 1 here, not plus equals, like a dumbass. And then we need to push. Node, void. And there's no need to do defer here. We just do this. Boom. Easy. Now, how do we know if we're done? I guess first we do like this. New LED state is this. New depth is node depth plus 1. And maybe this returns optional usize. If new LED state is equal to 0, we're done. I think. That sounds kind of right. Who's mad? Why is this not... Oh. That seems nice. Okay, and then here we just make our BFS, right? So we say like, var BFS is BFS. We have to have our buttons is... So I guess it's like start index is 0, and index is 0. Buttons is buttons, right? That's easy. And then our items is going to be our BFS buff. Where our BFS buff is a bunch of BFS nodes. And how many do you think we need? Like, surely we don't need more than like 5,000. 1,000? 5,000? Surely. Surely that's fine, right? And we're like, while BFS, like, while true, if BFS step depth, we return D. And this returns usize. Do we not need... Oh, so we have to say, like, for buttons, we initialize this thing. Do we press it with... Do we start by pressing? Probably, right? Maybe not. Because we need to make sure that we, like, hit this... If it's one press, we want to get kicked out by the loop. So I think we start with not pressed. So we're like, all these depth is 0 initially. LED state is the final state because we're going backwards, and from is equal to I. Okay. And do we actually need this? I guess we don't start with the initial button. We don't press the buttons. We don't need them. It's kind of just like this. That seems reasonable. Okay. Int cast here. Unused local variable on alloc buff. So true, because we are not allocating anything anymore, because we're fucking ballers like that. 90 is, if new lead state, is empty. Is empty. Return self inner is equal to 0. Easy. Another one of these int cast boys. Resolve pattern. Can we just say debug print here? 232? Is that right? 2327. Promising. 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 Dude, you love it when it just kind of works. You love it when it just kind of works. All right, let's try it on the real input, which I don't think we have written down anywhere yet. Save as day 10 input text. All right. Okay, so our breadth first search is starting to cause problems. So let's at least try making it circular. So we'll say self start index plus equals self start index plus 1 mod items len. Okay. And we'll do the same thing here. That will get us a little bit of room. Then we're hitting out of memory at 156. So here, it looks like we can have more than 10 buttons. I hope there can't be more than 16. Okay, 93, new depth. So this cannot be a U8, fine. Okay, bad news. It feels like we're getting stuck somewhere. So can we say processing line, this guy. Okay, and then I guess we say process like parsing buttons goes here, resolving pattern. I assume it's in here. Resolving pattern, yep. Yep. Okay, so we're getting stuck. So either we're not fucking hitting it, or it's broken. So can we let's see. New depth. New state. Okay, so he is trying stuff, but we're not getting there. We are not getting there, so something seems wrong. So I guess, can we, like, is this possible for us to do by hand, this line? Okay, so we are trying to get here. I guess maybe what makes more sense is for us to try a few steps of this puzzle, of this particular line, and see why it's fucked. It cannot by definition get that deep because you cannot press the same button twice. Yeah, but I guess like maybe wait, you can press this. You can apply the same button twice. Oh, you can't apply them twice. You're saying you can't apply them twice ever. I was thinking you can't apply them twice in a row. But you're right. With XOR propagation, like there's no point in trying them again. You are right. You are right. So what we should have is in here, instead of from being this guy, from should be a bit mask. Yeah. So from is equal to node from or one shift left by this. You can press it multiple times and this can be the answer. Wait, is that true? Hold on, let me think about this. I thought that if you're XORing, there's like a transitive property where even after, like if you do like ABA, BBAA, it's like the final state is one of B or A. Like, because of the fact that like the XORs will all cancel each other. I'm pretty sure that's true. Pretty sure. So if as using one shifted left by int cast I, and node from is not equal to 0. There we go. Or is equal, and yeah, and then if start index is equal to self end index, unreachable, we should be hitting this case. Nice. Okay, can we run this on the example again, just to make sure? Yeah. Okay, so what is special about where we're falling over? Where we exhaust all of our possibilities. Let's think. I think from equals 0 here. I think we're fucking up the initial press. Maybe? Or maybe my initial button state. I think I'm fucking up the initial state somehow. I think you only push one thing in the initial state, right? You push in the desired state with nothing input? Okay. That seems kind of right. But then we're still falling over, which is, I guess, is nice. We can just kind of write a test to figure out what's going on here. I mean, are they all reachable? That's a question that we should answer, right? So can we... Can I want to log what's happening here. So at each step, can we say, we want to print the depth, initial, final, as well as the button. Okay. So this is node depth, node LED state inner, new LED state inner, and button inner. Right? B inner. Okay. Do these look correct? Okay, first of all, let's maybe check that the buttons are right, actually. I'm still convinced the state being backwards doesn't cause problems. Yeah, we'll see. We'll see. I feel like it should be right, but I could be wrong. I could be wrong. Okay. Can we say buttons? And we go like for buttons items B std debug print button is this. And then we print the line as well, right? Yeah, press, okay. So here we have 0, 2, 3, 4, 5. Whoa, 0, 2. Isn't this wrong already? Zero. Oh, is it? Oh, backwards. Backwards. Sorry. 0, 2, 3, 4. 0, 2, 3, 4, 5, 7, 9. Okay. 0, 1, 2, 3, 4, 5, 6, 7. Okay. 0, 2, 3, 5, 8, 9. Yep. 0, 1, skip 2, 3, 4, skip 5, 6, 7, skip 8, skip 9. This feels right to me. 0, 4, 7. Great. 2, 3, 4, 8, 9. Great. And then 1, 2, 3, 5, 7, 8, 9. Great. That all looks right to me. That all looks right to me. And is your initial state reversed? I believe so, but I should double check that as well. I believe that they're following the same rules, right? Where the initial state, I mean, we can double check this too, right? Desired state is this. Desired state inner. Okay, so our desired state here has the lowest bit set, second this here, and then these two, right? So lowest bit is on the right visually here, but like we're always starting at 0 everywhere, so I don't see why this would be a problem. I do not see why this would be a problem. Yeah, I don't understand. I feel like we need to write some tests. Okay. Test button application, right? So if we have desired state is something like this. Right? Something like this. And we have a button that presses. How do we parse buttons? Init from button def. Okay. So we have one button that is like this. It's like he presses, oopsies. He presses button 3 and 5, right? 0, 1, 2, oh, sorry, 2 and 4. We should see LED state, init from buffer, desired state, and we should have button is button init from button def. Right? I'm pretty sure this is fine. Right? We have LED state. And is this not tried? Init from buffer. Oh. This should be like this. This is what he wants. Why do you have so many? Why do you have so many bits in button depth? Oh, because I'm not padding the desired state, right? The desired state is longer than what's shown here, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the maximum of these is 10 bits, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's just we're not showing the leading zeros here. You know what I mean? You know? Okay. I think this is fine. Apply button, and we are saying like, new state is this, and we should be like if try stood testing expect equal new state to be 0. Right? This is what we're expecting. Button def maybe. All right. Zig test day 10. Unexpected fuck. No spaces. Right? So the fact that this passes, I think means that like there's nothing wrong with like the application of a button to an LED state, right? This seems fine, right? And if we were to do like 1 here, we would expect this to be 1. No? Oh, sorry, 2, because it's 1 shifted left by 1. So I think this is all behaving the way I expect, right? Now, where I think that there's a bigger room for error is our breadth first search. That seems likely to have some bugs in it. So I think what we need to do is make sure that we are applying the right buttons after. How do we test this? How do we test this? Can we step once? Like, can we go like, I guess we just log what we were logging. And can we do like, okay, what is log? We're looking for buttons from the end. Okay. So we apply from the initial state. We apply 1, 2, 3, 4, 5, 6, 7, 8 different buttons. We are starting from the same initial state from all of them, which is 1, 0, 1, 0, 1, 1, with more stuff at the end, right? So then we apply 1, 0, 1, 0, 1, 1, 1, 1, 1, 0, 1, 0, 1, which means that we zero out the first bit. So these 3 bits get zeroed out, the 1, 0, 1 here. Then this bit gets set, 4th bit, 0, 1, 1. So, sorry, 1, 2, 3, 4, 5, 6, and then it's 0, 1, 0, 1. Yeah, so that seems right. And so I guess the options are, there is a bug with some button parsing. There's definitely an option there. However, we've checked all these, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I believe that all of these are correct. Right? We see nothing bigger than 9 in any of these. Everything is single digit, so there's nothing to worry about there. And we have a search to check that those will fall over. Cool. So then the other option is that we are pushing invalid state into our breadth first search. So can we do something like this? Can we say the button index as well? Right, so as we process button 0, right? Or so we process button 0 and we push in button 1, 2, 3, 4, 5, 6, 7. And again, let me just double check. 1, 2, 3, 4, 5, 6, 7, 8. Seems correct to me, right? So 7th button is no 0, 1, 2, 3, no 4, 5 is good, no 6, 79. All seems right to me. All seems right. And interesting. I mean, it does seem true as well that none of the final outputs in any of this are 0. Right? That's interesting as well. I'd check that you got the actual correct presses on the example. Yeah, that seems reasonable, except we're not really tracking those very easily. Right? Because we're not holding on to the state of like which presses we came from. But we could. So, okay, let's get rid of the circular buffer thing again. We'll keep every node that we've ever put in our breadth first search. I think that's a good trick here that we could do. And what we can do here is we can have like so this is more we're gonna rename this to like applied buttons. Boom, 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 boom. And then we will say from is usize, and on the initial node we set from is equal to std math max int usize. Okay. Then all we have to do here is say, on here we say where we came from. So this is node index. Like this, or yep. And then when we find the state, we can say what happened. I guess, wait, hold on. We don't have to do this, actually. I'm an idiot. We don't have to do backtracking for this to work. Because we can tell which buttons were pressed in the example. So we can just look at applied buttons. Buttons pressed. This is what I want to do. I guess it's kind of more here. Yup. So this is going to be node applied buttons or as you've seen 1 shift left by int cast I. Something like this. Something like that. And then can we do input.text like this? Oops, we lost that. We started throwing that from thing in here, which we don't want. Oopsies, fucked up the as U16. Brackets are in the wrong spots. One here. Get rid of one of these. Okay. So, in the example, we should press buttons 0 and 4. Hold on. Okay, so on the last one, it is 0 through 4 and 0, 1, 2, 3, 4, 5. So that's 0 and 1. Hold on. The fewest passes required to configure it is 2. The way to do this is pressing by buttons 0 through 4, which is the first 0, 1, and 0, 1, 2, 3, 4, 5. So 0, 1, and 0, 1, 2. Okay, so that seems correct, right? This 0, 0, 1, 1 matches that it is this button and this button. Okay, then on the other one, the first 3 buttons once each, which is not what we did. We did we did 0, 1, we did these 3. We did these 3. Which, is that correct? 0, 1, 2. Yeah, that's correct. Read the next paragraph. Which next paragraph? There's lots of paragraphs. So I think that's right for this one. And then, oh no, sorry. First 3 buttons once each. However, oh, here we go. 0, 2, and 0, 1. I see. The fewest button presses required to press is 2. I pressed 1, 3 and 2, 3. Which is the same, right? 1, 3, and 2, 3 is the same thing as 0. Then I'll turn on 1 and 3, and then toggle 1. Yeah, it's the same. It's the same. It's the same. What am I missing here? You press 1, 3 once, 2, 3 once, and 0, 1 twice. He doesn't explain every way, right? Because he's missing the one I did. So he's expressing many ways, but like, sure, it's the same. We still have, there's just many solutions. Yeah, I think that this is correct. Very interesting. Interesting. I guess the next question is, do we just have to manually solve it and figure out what we're doing wrong? We might, right? Which is a pain. Because to me, it looks like we've exhausted, as far as I understand the problem right now, we've exhausted every option and there isn't one. Right? Can we assume that every single one is solvable? You can write a test that XORs all of the buttons again and checks it against the current node. I'm kind of down for that, right? You're kind of saying, like, if we go back and we check all the buttons, if we undo all the ones we've pressed, we should end up at the initial state. Yeah. Yeah, I'm kind of down for that. There could be a bug there. You're right. For each button, we go 0 to button, I guess we check, like, okay, here we go. For self buttons, var, like, can we say, like, backwards test. So this is gonna be a node LED state. We can say something like if as u16 1 shift left by int cast I and node applied buttons, just this thing. If we have hit this thing, we want to do backwards test is equal to backwards test apply button B. And what we should see is that backwards test inner is equal to desired pattern. Right? Let's start there. Let's start there. Okay. Interesting. Can we run this on the example? Just like... Okay, this is not true. So have I fucked this up somehow? Maybe. What the fuck? That means that something is definitely not understood. Okay, that's interesting. So this is backwards desired. Then can we say like which buttons are pressed? No. Node apply buttons. So here we press the only button he's pressed is the first button. Or the second, sorry, the 0, 1 button. So 1, 3. He's only pressed 1, 3. Can we start, like, what is the button state? State, backwards desired. What the fuck are we missing? What the fuck? So I press 1, 3. So I start here. I press 0, 1, and 3. I should end up at 0, 1, 1, no? What the fuck am I what the fuck? State button. What the fuck? Whoa, 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 whoa. What the fuck? That's the 0th button. My button state tracking is wrong, I think. Applied buttons. applied buttons or int cast I, which is the button I just pressed, right? Apply button B. I is, what the fuck? Okay. Hold on. This should be here, my bad. I fucked something up. I was logging in the wrong spot and asserting in the wrong spot, which is confusing. Should be outside the loop after you've done them all. Okay, now that assertion is working correctly. I think the assertion should be outside the loop. Yep, you are right, and I'm an idiot. Okay. And then we also needed to fix the circular buffer shit because we were using that. And index plus 1% self items len. Oops. Am I stupid? Index 8191 len 5000? What the fuck? And index, oh. Better. Interesting. So the backwards assertion is correct, right? We're not asserting that we're not hitting a crash here that says like going backwards is ever incorrect. You know what okay. So there's a trick here, by the way, that I'm only now realizing, that you actually don't need a breadth first search because of the transitive property, where every combination, it's like you iterate from 0 to number of, like, 2 to the power of number of buttons, right? And that will create you a button mask that is one of the buttons, that is all the buttons in there. Could it be that your circular buffer is too small and overwrites some combinations? Oh yeah, we're probably not testing that, huh? Yeah, you're probably right. And index is equal to self start index. Unreachable. Or assert. That's probably it. That's probably it. Yeah, good fucking call, dude. You're a fucking genius. Oh my god. How is this happening still with so many nodes? Am I stupid? Okay, input example. Holy shit, dude. No, that 5,000 is only in one place. What the fuck? How is this breadth first search getting that deep? Checks all permutations, including older permutations. Oh yeah, we should probably check on push. We're only checking if we need to apply on pop, which is probably wrong, right? Yeah, it's like this check is in the wrong spot. Right? Yeah. Yeah, so this needs to be like in here somewhere. Oh no, no, because we're only pushing if each node doesn't have the applied buttons. Isn't it like 2 to the power of num buttons? Yeah, I guess so, right? So we have like 2 to the power of like. Yeah, I feel like I'm missing something. It feels like we should not need this many. Are we fucking this up? Self start index is self start index plus 1. Mod items line. And index. BFS will do 10 factorial. Yeah, I guess so, huh? There's probably something there. Because for each button. No, because we're only pushing if we haven't seen that button before. I think. That was my understanding. Also here. Give it a few gigs. Yeah, I mean, I guess we can try, but the number is insane. Right, so we must have a bug here. But yeah. Like, fuck it, right? Like, give it so fucking many. Oh, wait, we can't put that much on the stack. I'm an idiot. We can't put this much on the stack. Oh, maybe we can. Okay, we'll just do this. Stood heap page allocator alloc BFS node, and let's get like so unbelievably many of them. Just like, let's get fucking crazy with it. I don't think this makes sense, but if we give it enough space. If we give it enough space. Maybe. Hello? Oh, maybe it's this print as well. Yeah, interesting. So we probably are just pushing way too much shit into our BFS. Right? Like 1,000 nodes, not enough. What is the like limit here? Yeah, that's crazy. We're doing something stupid. I assume that we are pushing nodes and then rejecting them at the wrong place. But I will say you could fix this by just looping over all the numbers, right? Because again, we don't need to actually do a BFS because you can track this with a bit set as well. Because of the transitive properties. Like, whatever. Fuck, we should fix it. We should fucking fix it. But I guess first, let's just check that we got the right answer, I guess. Might as well. Yeah, Jesus Christ, dude. Why? Okay, so my understanding of what we've done here is that this shouldn't be insane like this. That's my understanding. Right? Because what do I think it should be? Oh yeah, maybe you're right that it is 10 factorial. Maybe you're just right. Because it's like, I have 10 buttons. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For each of these 10 buttons, I try all of the other 9 buttons afterwards. So here I do like 0, I try this. 1, I try this. 2, I try this. So this adds So this is 10 times 9 times 8 times 7 times 6. However, I thought that we should be discarding like extra combos. But yeah, maybe we just are using like an insane amount of RAM that we don't need. That seems likely. I don't know. Fine. Fine. I mean, what we've done is stupid. But let's read part 2 and then we can decide if we want to fix it. Let's read part 2, and if part 2 allows us to fix this, we will fix it. And if it does not, then we will not. Jesus Christ. Sorry, guys. That was a lot of time for I didn't allocate enough RAM. All of the machines are starting to come online. Now it's time to worry about voltage requirements. Each machine seems to be configured to exactly the specified voltage levels to function properly. Below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the indicator lights to increasing the voltage levels. The machines have a set of numeric counters tracking its voltage levels. One counter per voltage requirement. What the fuck are we talking about? I'm so lost. Below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the indicator lights to increasing the voltage levels. Okay. The machines have a set of numeric counters tracking its voltage. Okay, cool. So everything's 0, and instead of pressing the buttons to turn on off, we say add or remove voltage, I guess, probably, right? So voltage requirements like 3, 4, 5, 4, 7 mean the machine has 4 counters which are initially 0, and the goal is to simultaneously configure the first counter to be 3, second to 5, third to be 4, and the fourth to be 7. The button wiring schematics are still relevant. In this new voltage configuration mode, each button now indicates which counters it affects, where 0 means the first counter, 1 means the second counter. Okay, so a button wiring schematic like 1, 3 means that we push the button, the second and fourth counters would increase by 1. If the voltage requirements were 1, 2, 3, blah, 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 it would be 0, 2, 2, 4. Oh, I see. So now you can press each button multiple times and it like has a behavior that matters because we're not just XORing anymore. Wait, do we ever subtract? Do we ever subtract here? The button wire... Set to 0. Okay. Each time you press that button, they increase by 1. I see. So, yeah, only add. So it's the same problem, just our state changes. Right? Yeah, interesting. Interesting. Right, so now it's starting to look like this LED state is like upgraded, right? This now has to become, it has to be a buffer, right? I don't see a way around it because we have to count each one. And now, instead of encoding this stuff like this, we probably have some allocator here. Okay. And in here, we are... Oh, wait, the LED state doesn't exist anymore, actually. LED state's dead. Right? We need, like, another thing that's, like, voltage state. Right? And here our input is a bunch of U8 characters now. And we probably need to do some more like intelligent parsing here. So I think we are asserting probably that like it's like this, right? It's like squiggle 1, 2, 3, 4 or something, like 3, 4, 10. No spaces, but I think that there are double digits in here. So we're trying to do like iterator is 1. We're probably saying like if input 0 is not equal to open squiggle, then return error unexpected. Great. While it is less than input len, we do something. It is equal to std mem index of scalar at position. This is probably like well true actually. Oh, that's probably fine. Yeah, I think this is actually well true. Okay, so this is like in input, we are looking for the comma, and if we don't find it, it is the end. We should probably also assert that input at input len -1 is the end squiggle, right? And then here we should know that we're looking at, yeah, that's great. I guess it's kind of more like this actually. This is like end is this, and then we defer it is equal to end. This is the num end, voltage end here. Like this. Then we can do something like std format parse int of UH voltage input from IT voltage end base 10 probably, and we are saying that ret append probably. How do we get the length? I guess we can just parse twice. We just say like std. Is there like a count? This is input. We're looking for how many commas there are. Probably +1. Var ret const ret is alec alec. We need this many U8s or something. What language? This is Zig. Zig, 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 zig. Then we have like ret array list is array list of U8 init buffer of ret or something, so that we can go like this down here, not have to track the index ourselves. And then return inner is ret or something like this. Apply button. Our buttons can still be represented the same way. It's just now for 0 to num buttons. I have to do this. Num buttons. No, this is a single button def. Yeah, so function like num elms or something, num each button affects multiple outputs. Or max output, I guess. And this is like 16 minus count leading zeros of inner or something. Fucking weird implementation now, but whatever. And I guess this needs an allocator. Gross. Yup. So this guy is going to do ret is a dupe of self inner, and then we go like for 0 to button max output. We say like if button is set I, ret I plus equals 1, which is way more complex. Way more complex. That's okay. And then is set here is like this is self inner and as u16 1 shift left by int cast of I. Ew, it's not equal to 0. Gross. But we made our bed and now we have to sleep in it, or whatever the fuck the thing is called. Is empty. For self inner. If I guess we want to do minus equals actually. I think that's more correct. And then some buttons can't be pressed, right? Because they'll take us over the limit. I think this is, we'll just allow it to go over the limit. That is easier. Which of these are these? I think joltage T like this. I don't know, man. I don't know. If self lm is equal to 0, I guess we'll do this. I want to call something like, should I discard this thing? Is it like perfect, or should I keep it? You know what I mean? I think we want something that's like, jolted state action, which is like keep, discard, return, right? And it's like, process jolted state, and this will return a jolted state action, right? And here I want to go like, for JS elements, like if lm is less than 0, return discard. Like there's nothing to do here, right? We've kind of like passed the point where this is like a relevant thing to look at. And then I guess here it's like any any above, and then any above is like equals any above or lm is greater than 0, and then return like if any above, we return keep, and then if they're all 0, we're fucking donezo. I think it's like something like this, right? So now we're gonna have like BFS2, right? So we're gonna have like joltage BFS, and it's gonna be similar. We're gonna have a bunch of nodes. We're gonna have a start. We're gonna have an end. We're gonna have buttons. But here we have joltage state instead of LED state. And applied buttons is no longer tracked. Right? Cool. Then what? This is all the same. For each step, we pop something, we get a node. We don't do this backwards test anymore because it's not trivial. For each button we press, we don't do any applied button tracking. What's Tages tuned in? What's the purpose of the VLC plugin? I forgot to change the title. That's what the purpose is. Oops. AOC day 10. No VLC plugin on the docket at all, actually. Okay. So now we're not looking at is empty, right? Is empty is not like a joltage state thing anymore. I don't know why. Oh, because it's the wrong type. Joltage BFS everywhere here. BFS. Boom, boom. Okay. So now this is empty doesn't exist. So now I have to do like process joltage state on node LED state or something, right? So LED state is a bad name. This should be joltage state. But we need to like do something here, right? Like, where is the part where we did the application before? Oh, it's here, apply button, which is not. Oh, that still exists. Perfect. But he needs an allocator now. Okay, cool. But then everything else might kind of just be the same, to be honest. Okay. So then we have resolve pattern. So now we're doing resolve joltage. Who needs an alloc now? We can't get away from it. Okay. And I think a lot of this is the same now, except this is gonna use, we're all using the same alloc here. And we will not do any freeze anymore. Back to our, you know, our classic behavior. And then here, we're gonna say resolve joltage. And then we'll bring back the allocator. Alloc buff is going to be maybe we'll let it get kind of crazy, I think. Let's do like let's get him go let him go up to a gig. Fuck it. Let's let him get fucking crazy out here if he really wants. We'll let him go fucking insane. You can't fucking stop me. You can't stop me. And then we will do our little checkpoint here, though. FBA checkpoint is FBA and index, and then defer FBA and index is CP, and then we can do whatever the fuck we want. We can leak anything we want in here, and we'll be chilling. Okay. Okay, let's run on the example first. Let's run it on the example first. Which is mad because 343, he's looking at desired state as an LED state. But we want this as a joltage state, I guess. Oh, which is now just jolted state dot init buffer. Oh, so we actually need to do like a line reader let's like discard delimiter inclusive. I think inclusive, right? So we like discard till the end of this thing. I guess we can still actually read this if we want, but like whatever. Sure. Okay, this is desired LED state, I guess now. Like this, and then we have our desired state is parsed after button processing. So I think take delimiter exclusive. I feel like this was returning something, right? No. Okay. I think it's just this. Like, give me the fucking rest. But we'll see. Can we look at desired state? Yeah, sure. Does he need an alloc? Yeah. See in a couple years. Hey, we won't take that long. Okay. What's going on here? Init from buffer, stud mem count. Maybe it's like this. 43 is mad because init buffer took a pointer that he didn't want. Index of scalar pause needs to start at the iterator position. Maybe the other way. The position goes here. Okay. Parse int is failable, so we write try here. Wonderful. And then applied buttons on the new BFS is garbanzo. We don't need that shit, dude. Same with on init, dude. Oops. Oopies. Okay, here. And then this index is not used, which is interesting. And then this is not used. No field name Alec. True, huh? Let's let him get fucking in there, dude. Dupe at 54 needs a type. It probably needs to be tried while we're here. 54 is mad because self inner here is I16. Oh, oops. Expected bool. Okay, 257. Right. So here we're actually switching on this. And with this thing, it's like return. If we return, it's like we're donezo. Steve, oh, thank you for the tier 1. Much appreciated. If it's discard, we continue. And if it's keep, we do nothing. No LED state, 264. So true. Doltage state. JS, I think I called it. And then this guy needs to try. Expected type this, found that. What the fuck? Oh, because this thing is failable now, which means that this thing needs to write try. Because we need to allocate. So true. Am I stupid? Expected type U size found. Oh. No, I'm lost. I feel like this should work. Found you. Oh. This guy's failable. I see. Which means this guy needs to write try here. Unexpected. Okay, so our parsing of this is fucking wrong. 37. Let's see. Yep. You gotta trim that motherfucker. Gotta trim that motherfucker. Or you just do this. Pressing buttons. Invalid character. At 47. What? Oh, our int parse is wrong? Parsing int like this. Input from IT joltage end. Am I doing something again? So, something fucking brain dead? Yeah, probably, huh? So this is just empty, yeah. So if IT is equal to joltage end, break. I guess we do need a way to get out of this loop. Okay. That seems bad. Probably forgot to memset something, right? Probably forgot to do something. Probably. Actually don't know. I mean, our desired state does look just like fucked, right? This is supposed to be 3, 5, 4, 7, and we just get like negative 2, 1, 4, 8, 6 everywhere. You know? So like, what the fuck is going on there? Am I stupid? It does seem like he's just, oh, +1. +1. +1. There we go. And then while IT is less than input len. There we go. Much better. Now we are still freaking the fuck out here when we run into space, but that's okay. Let's just add more space. I mean, this is insane to happen on the example problem, right? Does seem kind of fucking crazy. And he's just like trying forever, so there's something wrong here. Something wrong. Can we look at like what the fuck he's trying? Because what he's trying is fucking stupid. Surely. Surely. Trying this guy. We're clearly doing something fucking stupid. Okay, so there are some in here with negatives, which is bad. I'm definitely seeing some with negatives. It must be that, like, what we're pushing here is fucking stupid, right? Or does it really just take long? There's no way it should just take this long. There's no way. I don't believe it. I don't believe it. So we start with one node. For each button that we could press, we check if this is something that we can discard. If we can discard it, we don't push his children. We don't push him. You can check the depth because it will be the sum of all presses for the example case. Oh yeah, you're saying like in the example, like it should be on the first one. 1, 2, 3. No, hold on. Let's see. The first one, 12. So we are just not at 12 yet. Right? We're still at 8. Optimize, release. And then I guess we just do like std debug assert that node depth is less than 13 or something. Holy, I mean, we do. Oh, we ran out of fucking memory again? Dude, this is fucked. Am I missing something? Is this just how you have to do this shit? Like, there's no, like, I'm doing something fucking brain dead. It has to be, right? There is no way that it is reasonable to do this. Right? It means that, like, we must be missing something. Right? The idea of just doing a stupid breadth first search can't be right. It can't be. Interesting. Wait, is this actually fucking hard? Is it actually hard? Okay. Is there something to draw here? Is there something to draw here? Holy fuck. So I'm just trying to think. Because we have two options here. One option is we try to finish this today. And if this is going to be hard, that could take a long time. And we are already past the time where I would normally end stream. The other option is we start and we finish fast. Seems kind of unlikely if we're going to have to do a whole new strategy. So it might make sense to defer part 2 of day 10 till tomorrow. But then it's kind of shitty because then I have the opportunity to think about it off stream, which, like, makes it not fun anymore. So, okay, let's think about it a little bit more. And then we'll figure it out. We'll decide what to do after. Okay, so I have buttons. Let's start with 2 buttons. 0, 1, 1, 0. And 1, 1. Right? And we want to get to 3, 5, right? Obvious solution. Press this 3 times. And press this twice. Now, how do we decide that, though? How do we decide that? It feels like there's something about, like, combos of buttons, right? Like, depth first search? Maybe I'm stupid, but I don't see how that's possible. I guess I guess the answer there is that you're exhausting all options. So you're checking maybe more options because you have to hit every single one. But your memory cost is way fucking lower. Right? And since you know that your depth is less than 12, you know that that's not that bad. You still are going to like rail CPU time though, right? Like the overall CPU cost I think is going to be around the same, and this is already like surprisingly long. Surprisingly long, which makes me think that there's some trick here. There's some trick. I just don't, I can't find it, right? So like in this scenario, you know, you can kind of like reduce the problem in this scenario by kind of saying like -3, right? Like there's something about like you find the biggest set and you use that one. I guess there's also something about you just spam every button as many fucking times as you can. You don't really know that though, right? Like if I spam this button like 3 times, that works here. But like what about a scenario that's like this? Here, let's see if we can design one. 0, 0, 1. 1, 0, 1. 1, 1, 1. Right? Like, there's something here where if you were trying to get to, I don't know, to 3, 4? No. 2 in the middle. Oopsies, what I was do. Maybe that does work. 2 in the middle. No. Okay. 0, 1, 1, 1, 0, maybe? Maybe it does kind of always work out. So I don't know what I'm looking for here. It just feels like clicking this one as many times as you can is not correct. Maybe I'm looking for something that's more like 1, 1, 0, 1. This guy clicks most of the things. Then we have 0, 1, 1, 1. And 1, 0, 0, 0, 0 or something. And we're trying to get to, I don't know, 4, 3, 1, 3. Here, fuck. Okay, I was thinking like, so you click this one time and you spam this one. I don't know. I feel like you could construct some combination where you can't greedy search, but I haven't been able to like construct one myself yet. Interesting. Okay. I don't have an answer, and I want to think about it more than I think I have time to do today. So I will try to soak on this till tomorrow, and I will just do my best to avoid looking it up. And I mean, we've avoided like looking it up before now, so it shouldn't be hard to avoid looking it up before tomorrow. And then we'll maybe put some time thinking into it tomorrow, and if we still can't get there, then we give up and we look up the answer. Maybe that's the play. What time is the stream, smiley face? We'll probably do this part at 2 tomorrow. 2 p.m. So an hour and 20 minutes ago. 4:20, blaze it. Sorry. So thanks for watching, guys. Apologies, I've been like not reading chat in like the last minute or two, like the last couple minutes, because I'm like trying to avoid spoilers for myself. So thanks for watching. If you like what we saw, we stream most days 12:30 to 4 o'clock Pacific time. It is 4:20 now, so anywhere between 4 hours ago and now is when you just expect to see us live. We will do part 2 of this one probably tomorrow at 2, which is 2.5 hours ago. So yeah, see you then. YouTube, peace out. Twitch, let's find someone to raid.